Alright, so I think this is recording. Take a look at problem number 9 on this inverse functions. We are given a function, we're asked to find the inverse, and also asked to determine if this inverse is a function or not. When I look at this, I notice several things. This f of x is a quadratic function because I have an x squared, and the parent function is just your basic x squared that has been shifted to the right 4 units. Then was that the same problem as last time? It is, okay, but the difference is, I thought that looked familiar. The difference is here they're going to take this parabola and only consider the left hand side of it. So let's continue our discussion. We recognize it's x squared. If I think about what the graph of this f looks like, a parent function with the vertex here at the origin is I call it g, is x squared. The minus 4 shifts this to the right 4 units to where the vertex is now at 4, 0. The 6 vertically stretches it, so the graph now looks more skinny. It doesn't open as wide because at this x, the height of this has now been stretched to 6 times the distance away from the x-axis that it was. Alright, now finally the plus 12 pushes this up 12 units. So if you look at that last video so far, I think I'm saying the same thing. And we have a parabola with a vertex here at 412 that opens upward. Now the difference between this problem and problem 9 and the difference in problem 8 is they have came in and restricted my domain. I don't know why, but they have. We know that in problem 8 the domain of the original function was all real numbers, and then when we switched x and y, that made the range all real numbers. But here they have come in and said only consider the left part of the graph, only consider the points on the parabola that have x coordinates that are less than or equal to 4. So they are only looking at the left side of this parabola, left from the axis of symmetry. Remember that vertical line that goes through the vertex. So where last time my parabola failed the horizontal line test, this time it's passing the horizontal line test because they removed the part that was making it fail. They removed this part. Without that x less than or equal to 4, it would, if it had domain all real numbers, well, it'd be the answer we did in problem 8. But now with x less than or equal to 4, since this is a one-to-one function, I know that my inverse relation is also going to be a function, and not only that, a one-to-one function. So keep that in mind. Oh, now remember too that this vertex, that all the points on this parabola have y coordinates that are above the 12. So I know, let's change to black, that my range, the y values are bigger than or equal to 12. Alright, so I'm going to erase this. Now, rather than using function notation, this f of it, I'm going to use x and y notation. And if they want me to, the idea of the inverse switches the domain and range. So in my equation, I'm going to switch x and y. Everywhere I see a y, I'm going to write x. Everywhere I see an x, it changes to y. Now, like I said, we're switching the domain and range. So now x is no longer less than or equal to 4. Look at this. This y now becomes that x is greater than or equal to 12. And it's y that's going to be less than or equal to 4. Alright, and that's going to become important, especially this y less than or equal to 4 near the end of our answer. With each equation, these inequalities come along with it, I just get kind of lazy and I don't write it each time. Alright, on the right hand side I have two terms. This first term has the variable that I want, the y. I need to get that by itself. I'm going to get rid of the plus 12 by subtracting 12 from each side of the equation. So over here I'll have x minus 12, and over here I'll just have that first term. Now this first term has two factors, and it's this factor, the y minus 4 quantity squared, that has my variable of interest. I'm going to divide both sides of this by 6 to get that factor that has my variable by itself. And now I'm going to write the y minus 4 quantity squared on the left hand side and write this fraction over here on the right hand side. To get rid of this exponent of 2, I need to take the square root of the left hand side. To balance the equation, I need to take the square root of the right hand side, but when you take the square root of a variable, it's going to introduce a plus or minus into our equation. On the left hand side, now that exponent 2 is gone, and I have this plus or minus x minus 12 over 6. Now, when I look on the left hand side now, I see two terms, and the term that I want to get by itself that I'm solving for y is there. I want this y by itself, so I'm going to add 4 to both sides of the equation. So I have 4, I have plus or minus the square root of x minus 12 over 6. Now remember, like I say, I'm lazy. I should have been, with each equation, writing this after it. And that becomes important here in just a second. This plus or minus, that's just shorthand notation for two equations, so everybody is getting a little bit lazy by putting this plus or minus there. I'm going to separate this into two equations. So that I'm going to use the minus right here for this equation, and over here I'm going to write my positive 4 plus. That's what that plus or minus means, is that you have two equations. Well, we've seen it before that if you have plus or minus in an equation, it's not a function. Every x is supposed to have one y. If I plug an x into here, this minus sign is going to give me a y, and then the plus adding is going to give me a different y. But I knew when it failed the horizontal line test that it was not going to be a function. But hold on a second, because of this x less than or equal to 4, this is not like problem 8. This passed the horizontal line test. So wait a minute, I've got something going on here that's causing us a headache. Well, let's take a look at the x greater than or equal to 12, but more specifically the y less than or equal to 4, because this is going to be the key in helping me to understand this problem better. What do I have here? Well, on the first term I see a 4 here, and I also see a 4 in this equation. Each of these equations has the same expression underneath the radical. So, and I also know that this radical is called the principal square root, and I know it's always positive by definition. Well, it's always non-negative. It's always 0 or positive. I need y to be less than 4. Over here, I have 4, and I'm adding some positive amount. That's making these y values bigger than 4. I need the y values to be less than 4. If I look at the first equation, it starts, here I have y equals 4. For different values of x that are bigger than 12, we're always taking away a positive amount from 4. So this is the end result after this subtraction is a number that's smaller than 4. Okay, that's what we want. So we throw out the plus because we know that we need y less than or equal to 4, and now this guy is it is a function. In fact, it's a one-to-one function, and I can come in and use my inverse notation. They called it F. I know that this is F inverse. And the x greater than or equal to 12 has to be true, because if it were less than 12, like 11, 11 minus 12 would be a negative number, you know. And now that I took care of, I know that I don't even have to write down this restriction, y less than or equal to 4. Guaranteed it's going to be less than or equal to 4, because I picked the right equation that always results. So now all of a sudden, this restriction that I was saying needs to come along for the right along each equation, now by picking the right equation here and throwing this one out, I no longer need to write that. It's implied by the equation. So my final answer is that I knew at the beginning of the problem, when I graphed it and the graph passed the horizontal line test, I knew my final answer here was going to be a function. And now it's a square root function. And we can see that it is shifted to the right, well, 2 units. Because remember, I would rewrite this. Maybe we should do that real quick. 4 minus, the x gets divided by 6. So to divide by 6 is the same as to multiply by 1/6, and the 12 gets divided by 6. So this graph takes the basic square root function, shifts it to the right 2 units, has a horizontal stretch by a factor of 6, reflects it across the x-axis, and then lifts it up 4 units. But anyway, this is the inverse, and that is my final answer for 9. I hope that helps.